Good morning, one and all. I am B. Rahul. I am from CSCC section, and today's my tech talk topic is a massively parallel multigrid method for a finite elements. Introduction. For a multigrid method, it can be categorized into two types. For geometric and algebraic, the former also known as the full approximation scheme, FAS, multigrid involves a hierarchy of meshes cycling between the fine and core grids, and the descended equations are evaluated on every level. In latter, in course level equations are generalized without any geometry and redistribution on the course level. A feature that makes algebraic multigrid particularly attractive for the use of an unstructured measures. Introduction. Multigrid method is ideal for solving the Poisson-like pressures or pressure correction equation such as simple method, which will be further discussed in the next session. Conceptually, the multigrid method can be described in the following forcing on the system of the equation. If y equals to b, intermediate solution of y are obtained if this system is solved within an iteration method after some unspecified numbers of iterations. The residual r can be defined as if I equals to b minus r by also defining the errors or the difference between the true intermediate solutions e equals to phi minus u, and subtracting equation 5.95 from equation 5.94, the following relationship between the errors and residual is a equals to r. During the multigrid cycle, the matrix coefficient of A and the residential and the transferred from a finger grid to a coarser grid through volume weighted restrictions. After obtaining the converged solution of the error, the prolongation of a computed corrections on the coarse grid and the transfer to the next fine grids through the trilinear interpolation. The simplest choice of a multigrid cycle can be described by the typical V cycle with 5 different grid level efficiency may be improved by the decision to switch from one grid to another on the rate of conversion through the combination of UV cycle or all other possible combinations. The optimum choice of a parameter is problem depends, but their efficient and performance is not as dramatic as for the single grid method. You can see the above diagram. This circle represented intermediate solution, square box represent contiguous solution, convergent solution. It has 5 levels 1, 2, 3, 4, 5. These levels are known as grid levels. The relation between one intermediate solution to another intermediate solution is restriction, this RMR, and prolongation. Schematic representation of a multi-grid method using V-cycle. With the help of V-cycle, we can draw a diagram W. It consists of restriction, prolongation, and it has 5 level of grid level. Parallel computing. We use an additive version of a multi-grid method for the solution of the equation system. The so-called BPX preconditioner, this requires an outer Calero interacted solver. This approach has been the advantage of an optimal big of one condition number, and there are optimal order big of an implementation available even in the presence of the degraded grids. The implementation is similar to the hierarchical basis transformation, requires one auxiliary vector but enjoys a very much better condition number than the hierarchy basis required method. This implementation is simpler by the hierarchy method transformation. It only requires one auxiliary vector, and it also enjoys the better condition number of the hierarchy basic methods are required. Two loops over all nodes are necessary. One of these restriction operations and one from the prolongation. It consists of two loops overall all the nodes are necessary. One of the restriction operation and one for the prolongation operation. One is for the restriction, another one is the prolongation. They can be both implemented as a tree traversal. However, by ordering the nodes in the right way, two ordinary loops overall nodes is hash table, insufficient, one forward and one backward. In the pressure equation described by this slide explains about the variable order multigrid method. The presence pressure equation described is solved by the variable order multigrid method. In equation level, UA star denotes the fractional step velocity. Alpha is the parameter determined by the time integrated scheme. The overbar denotes the interpolation from the collaborated location to the stagerated location. In the variable order multigrid method, the unsteady term is added to the pressure equation. You can see the equation d square p to the power of n minus 1 by derivation of x square equal to 1 into derivation of ux to the power of x1 by delta t into derivation of x. Okay, in this slide we came to know this is described by the solved variable order multigrid method and is the time integrated scheme. Overall, it denotes the interpolation from the collaborated location to the staggered location. In this variable order multigrid method, the unsteady terms is added to the pressure equation. In this multigrid, we will add unsteady terms to a pressure equation. The pressure equation, elliptic equation, is transformed to the p to the power of n plus 1 by derived t equals to derivative square pn minus 1 derivation x square equal minus 1 delta t d power x. Equation 12 can be solved by the variable order method of lines. The spatial derivation are described by the aforementioned MDQ method so that the equation is reduced to the system of ODEs in episodic time. You can see the above equation. It is an ODEs in episodic time equation. This system of ODE is episodic time is integrated by the untraditional RRK scheme because of its wider stability region. The RRK scheme can be written by P to the power m plus 1 equals to P to the power of m plus 2g1 into g1 comma g3 bar equals to g1 bar comma g1 bar by g3 bar g3 bar. G1 bar equals to delta T L bar PM bar. G2 bar equals to delta T L PM bar plus C2 G1 bar. G3 bar equals to B1 G2 bar. Where delta T and M are the episodic time step and the level and the operations such as G1 bar and G3 bar denote the inner product of the vector. These G1 G3 are the denotes the inner product of the given vector. G1 and G3. Also the coefficient B1, B2 and C2 satisfy the relation. By satisfying these three above relation B1, B2, C3, B1 plus B2 equals to 1, C2 equals to minus 1 by 2. In addition, the multigrid technique is incorporated into the method in order to accelerate converge. Then the same order of spatial currents accuracy as the momentum equation can be specified. From this above slide, we came to note the specific time level as operations such as it G1, G3 will denote the inner product of the given vector and also these coefficients are satisfy the relation B1 plus B2 equals to 1 and C2 equals to minus 1 by 2. In addition, the multigrid technique is incorporated into the method in order to accelerate the convergence, then the same order of the spatial accuracy as the momentum equation can be specified. Thank you. By the above slide, we complete our PPT presentation.